This is going to be the very first video of linear algebra, and this is going to be the series of lectures. And in this video I will start from the very basic of linear algebra. uh, Actually I wanted to say the evolution, but the evolution of linear algebra is not that uniform like the abstract algebra, because the evolution happens in throughout phases. So we need to understand all the things one by one. So first of all, before going to the evolution, I will definitely tell you the evolution, but not at all. So I will try to tell all the evolution in parts. So before going to that, I will try to say that what is actually linear algebra is, and what is the difference between linear algebra and abstract algebra. There are a lot of difference between linear algebra and abstract algebra, but for a beginner to understand the difference, in abstract algebra we deal with we'll deal with polynomials. That's mean polynomial equations. That's mean, let's say any nth degree poly x to the power n plus, let's say x1 x to the power n minus 1, and let's these kind of things, and ultimately a n equal to 0. We polynomial equations in abstract algebra. But in linear algebra we deal with the system of linear equations. That's mean ax plus by equal to, let's say, c. Okay, dx plus ey equal to f. So this is the system of linear equations. So, okay, in linear algebra we deal with this kind of equations, and in abstract algebra usually we deal with this kind of equations. If for a beginner, understanding this is very much important. Okay, so now one thing that also we need to understand is what is linear. Okay, this is, I mean, there is not a particular definition of linear or linear, but we can define the definition in, let's say, linear equations, the definition of linear equation, the definition of linear function, linearity. So these are the definitions, but there is no particular definition of linear. But still, if you, in general, if I want to describe a relationship or functions where variables are only multiplied by constants and add together with no coefficients. Okay, roots are multiplied by each other. That's mean, let's say I have 2x plus 3y equal to 4. This is a linear equation. Okay, now if I do like this, 2xy plus 3y equal to 1, this is not a linear equation because I multiplied two variables x and y. This is not a linear equation, but this is a linear equation. That's mean each power, actually power of the variables will be 1. Okay, so and the two variables will cannot multiply by each other, and only thing that can be multiplied by the variables is a constant. Okay, so this kind of thing you can understand as a linear equations or a linearity. Okay, in roughly speaking. Now algebra means where we find the roots. Okay, so system of linear equations. In the abstract algebra we find the roots of a polynomial equation. In linear algebra we find the roots of system of polynomial equation. That's mean like this kind of, if this kind of linear equations, system of linear equations, we try to find the roots of this kind of system of equations in linear algebra. Okay, so these are the basic things that I wanted to tell you about linear algebra. Now, as the linear algebra study of the linear equations, system of linear equations, then first of all we need to understand that why the linear equations arose. Okay, let me take an example of a linear equation. Let's say 2x plus 3y equal to 1, 2x plus 4y equal to 3. This is a system of linear equations. Maybe we can add three variables, 2x plus 4y plus 5z equal to 1. Okay, ax plus 4y plus z equal to, let's say, 2. I am just writing randomly. This is also a system of linear equations. If three variables but two equations, I can take one more equation, add one more equation on it. Let's say 2y plus 3z, 4. Let's say 4x plus y plus z equal to, let's say, 5. This is also a system of linear equation. Okay, three variables and four equations. This is also a possibility. Okay, dealing with all those things is a study of linear algebra. We need to find solution of it if there exist. This kind of solution also exist. If three variables and two equations, there are also possibility of existence of the root. Okay, so all the things is possible to find the solution. So we will study these things. Before going to the equations, we need to understand one more thing, is that how actually linear equation, you know, arose. Okay, this is very much important. Uh, Actually, long before, okay, in China, we first saw a method of solving system of linear equations. Okay, in Zhao Dynasty, China. Okay, on a book. The name of the book was Nine Chapter on the Mathematical Art. In that book, in the eighth chapter, there was a method for solving a system of linear equations. Okay, like I mean this system of linear equations. These are all linear, and this is a system. Yes, there are four equations. Okay, for for in this case there are two variables. In this case there are three variables. Okay, in that book there was method for solving two, three, four, five variables. Okay, solving the method of solving the system of linear equations. Okay, and this was the actual, you may say, the actual start of linear algebra. Okay, in this video we will try to decode how they solve such kind of equations. Okay, taking taken in for two variables and for three variables. Okay, all the methods are same. I mean, we can do apply the same method for two variables, three variables, four variables, and any finite number of variables. Okay, same method. Before that, let's try to understand why a linear equation actually arose in those time, and how we able to understand and how we actually generate a system of linear equations. So let me give you an example. Let's say you are a merchant of ancient time. Okay, and you sell rice and dal. Okay, now you have two combo. Okay, rice. You sell rice and dal. Now you have two combo. I mean, you sell rice and dal like this. Let's say either you have to, for 10 bag of rice, 10 bag rice, and 15 bag dal, cost, okay, 30 rupees. And this is a offer one can buy, or one can buy this offer, that 15 bag rice and 20 bag dal, cost 40 rupees. These are the two deals you do with your customers. Okay, I mean, these are the two combo offer you have. Okay, you don't buy the rice or dal, bag of rice or bag of dals single, I mean individually. You buy in combo. So now, after selling all rice and dals, you ultimately end up with, let's say, three bag of rice, and now you have three bag of rice and let's say four bag of dal. Now you want to sell them, but how can you sell them? Because you don't know the individual rate of one bag of rice or one bag of dal. You know the rate of the dal and the rice, I mean, in in combination form. 10 bag of rice, 15 bag of dal, 30 rupees, and 15 bag of rice, 20 bag of dal, cost 40 rupees. But you don't know, but these are not making any combo in this. Okay, 3 bag, 4 bag of dal, 3 bag of rice. Okay, so but you want to sell them, so you need to understand, so you need to know the actual rate of rice and dal. So how can you know the actual rate of rice and dal? In particular here, these kind of problems are facing, ancient peoples are facing these kind of problems, and for this particular case they try to solve, they need the tool to solve the system of linear equations. So how they deal with it? They just take two variables. Let's say the rate of one bag of rice. Okay, one bag rice, the rate of one bag rice is, let's say, x. Okay, and one bag dal is, let's say, y. That's mean 10 bag rice and 15 bag dal cost 30 rupees. Okay, and 15 bag rice and 20 bag dal cost 40 rupees, because rate of one bag is x. Okay, so x into 10 plus 15 into y dal equal to 30 rupees, and the cost of one bag of rice is x, so 15 into x into 20 into y equal to 40 rupees. These are the things they have. Okay, so but the problem here is that how can you solve it? Now in our modern intuition we can solve the equation very much easily. Okay, how can you solve it? There are a lot of ways, but one of the way that can we solve this equation is like this. To solve it, I just take 5 common from here, 5 common from here, and just divide it from in this here. Okay, and ultimately we end up with this. Okay. Now, one of the process we do is that we multiply here into minus 3 by 2. Okay, so multiplying it, the number one equation with minus 3 by 2, we will end up multiplying it minus 3 by 2. Okay, both the side. Now we will end up with 2 cancel, minus 3x minus 9, 3 into 3, 9 by 2 equal to minus 3, 2 into 6, 3. Now we end up with minus 9, and this equation remains same, 3x plus 4 equal to 8. Now what we do in elimination, actually this method is called the elimination method. I think everybody is familiar with it, okay, in their lower classes. So we just, what we do is that we just eliminate the x term. We just this one and we add it with this. Okay, 9y by 2 and ultimately 8 minus 9. Okay, so ultimately calculating it, simplifying it, we will have y equal to 2. Okay, now what we do is just put the value of y in this equation, and ultimately we end up with x is that x equal to 0. Okay, so in this case we solve the equation. Now one thing, I do all those things so much, I mean how why break all the things very, in this kind of way. So let's try to decode all the things what I did actually. First of all, in this kind of equations, okay, I have two equations, so I take the common. That's mean actually what I did, I actually divide the both equations by 5. That's mean if I divide the equations by 5, that's mean this thing is, this thing is right, because this thing don't change the value of x and y. Okay, dividing by any number. Now one thing I again did is that I multiply the number one equation by minus 3 by 2. Okay, I multiply the number one equation in minus 3 by 2. That's mean this is also a legitimate operation. Okay, I don't multiply 2 with any other number, but I multiply the number one equation with minus 3 by 2. That's mean multiplying any equation, this also doesn't change the value of x and y. Okay, then what I did, I just tried, why I multiplied number one equation with minus 3 by 2. I just tried to take the, I just tried to eliminate this x. Okay, so to eliminate this x, 3x, I see this coefficient 3 and I just want to make the coefficient here 3. So just multiplied minus 3 by 2. That's mean 2 and 2 can be cancelled out, and we will ultimately end up with minus 3, and after adding them they will cancel out. That was my motivation. So for this I choose minus 3 by 2 very cleverly. Then after multiplying it, I add it. That's mean after the multiplication I add this equation with this. I add my number one equation with this, and ultimately this, the variable x cancel out. We only have the y variable. Okay, and we can solve it easily. Then just we substitute the value of y in number two equation, and we have the value of x. This was our motivation. So these all things we did. So now this is the exactly thing what Zhao dynasty people read. In the 9th chapter of mathematics. Okay, in the book. So let's try to decode what they did. Okay, let us take this system of linear equations with three variables x, y, z. Okay, so how can I solve this? So the ancient people noticed that in our previous case, that in equations, if I change the equations, if I multiply anything with any of the equation, still the value of the variables will still remain same. Again, if we add or can subtract, okay, this is also legitimate. And one more thing is legitimate here. This is swapping up. Let's say I do this, I just write this equation, okay, in the upside, in first equation. Okay, this thing is also legitimate. I just swap the two equations. Okay, these things actually the ancient people noticed. The Dao dynasty China people. Okay, so they made a very interesting method to solve this. One of the big disadvantage in this case is that this is very much messy. When I was solving in our previous, if the number of variables increase, okay, the method become very much messy. Computing them become very much difficult. okay, dealing with them. Actually, I think you guys also face this same kind of problem. If I gave you four variables, four unknowns, the here is three you can still handle. But if I give you four unknowns, five unknowns, this is going to be very much difficult to deal with the previous, method. So we need to have any method so that we can solve it for large number of unknowns. Okay, large number of variables. So let's see for now three variables. Okay, then we will proceed further. They noticed that as these things are legitimate, so I can writing the variables, I mean we are writing the same variables again and again, so somehow we can, if we can able to eliminate them, we will not write them. Okay, because we are just working with the coefficients, we are not working with the variables itself. Okay, so they, what they did, they just eliminate, neglect the, not eliminated but neglected the variables. Okay, 3, okay, 2, 3, 1, 3, 2, 1, okay, and 36, 34, 39. Okay, so they did this. Okay, so now this is the equation, just I don't write the variables here, other thing is everything is same, I mean the equality sign, you can understand this as the equality sign. Okay, so they noticed that, I mean in our last step we already noticed that the swapping was legitimate, we can swap them, so I just swap them, so I write it here, I swap these two equations and ultimately we end up with this. Okay, now what our motivation, our in the last example, if you noticed properly that use, so let me show you the last example. In our last example, our motivation was to eliminate this x, to eliminate this x. Okay, using this, to eliminate the x using this. Okay, we just, so that we multiplied it something so that the coefficient become similar and we just add them. Okay, this thing we did in our last, in this. Okay, so we will apply the same thing in for the three variable case. Let's see, we have this. So now carefully notice that if I multiply here by -2, okay, and add it, then this will become 0. Okay, that's mean if I multiply here -2, all the variables in all the equation -2, and add it with it, that's mean this x variable will cancel out from this equation, number 2 equation. So, and one more thing, similarly if I multiply here -3 and add here, so all the x variable will disappear from this equation. Okay, so we will just end up with y and z. Okay, so that's mean in from third number equation we able to eliminate the x variable properly. Okay, somehow, and sorry, so not only just third variable, from second variable also we able to eliminate the x and y using this variable properly. Okay, so let's do it. So what we will do, just this is, let's say this is the row, so we will, what we will do, we will multiply here with 2. Okay, number 1 row we will multiply here with -2. Okay, and in number 1 row we multiply by -3. Okay, and add it to 2 number row, and this is in 3 number row. Okay, so ultimately this is going to be 0, because if I multiply here -2, so let me write it in more explaining way. Okay, so that you can able to understand. Here you can see that, let's say just like the equation, because in a equation we can multiply -2 with number 1 equation. Okay, and and subtract it from number 2. Okay, so yeah, this will remain the same as we multiply it from this, and ultimately has add it in the number 2 equation. So the ultimately number 2 equation becomes this. Okay, again we multiply this to make this one 0. We multiply sorry, -3, multiply -3 with this one, and ultimately we add it to number 3 equation. We can do this. Okay, so we end up with this, and to make this one 0, this variable 0, we multiply number 2 equation with -3. Okay, and add it with this, and we end up with this, that also this coefficient is 0. That's mean one thing that is noticeable here is that ultimately our x coefficient, y coefficient is 0 in the number 3 equation, and we just end up with 12z equal to 73. So we can find the value of z here easily. Okay, and putting the value of z in the number 2 equation, as there is variable x is 0, we can find the value of y very much easily. Okay, now similarly we know the value of y and z, and we just put the value of y and z here, and we ultimately end up with the value of x. Okay, so we just did the same thing because these things are legitimate, you know these things are legitimate in your lower classes. Okay, so we did the same thing, just we just ignore the variables x, y, z. Okay, we just ignore the variables. You will notice I write 1 2 3. Okay, these things, just I don't write the equality and I ignore the variables. Okay, then I do the same thing. I subtract this one, multiplying -2 in this one, multiplying the row, multiplying -2 in row number 1, I subtract it from it. Okay, again I multiply sorry multiply -3 in this one and then subtract it from it. Again I multiply -4 in this one and subtract from it. I do the exactly same thing. These things are legitimate, so I just saw these things and I ultimately write these things in here. Okay, so this make me shorter. Okay, so ultimately this is the z. So ultimately you can write the equations ax plus 2y plus 3z equal to 36. Okay, now minus y plus minus 5z equal to 38. Okay, and 12z equal to 73, just like this. Okay, and ultimately we can solve this. This is the thing. Now this was the process what the dynasty people in China are doing, and interestingly this is the same technique in modern methods. We solve the system of equations like this. This is called the Gaussian elimination, exactly like this. Okay, so I just wanted to show you the pattern. This is a very much advanced thing now, and this is connected very much, I mean in very much fundamentally this is connected. You can see this exactly the the basic algebraic operations we did in this form. And one more thing that is noticeable here is that, can you see the matrix formation? Maybe this is not a matrix, but this is looking like a matrix. The concept of matrix, I mean you can see the pseudo matrix is here. Okay, so this is very much important to understand the concept, how the matrix came. Okay, how the solution of a system is very much linked, because some guys who already know about the row operations, they know that 3 operations are used. We can swap them. 1, we can swap them. Okay, 2 is we can multiply, and ultimately we swap them, we multiply something, okay, with any of the row, and we can subtract them also from one row to another one. These are the 3 operations we can do. Okay, so you can see why we chose these 3 operations only, why not the other operations, because these only 3 operations are legitimate here. Okay, we saw that these operations are legitimate for solving a system of equations. For this we just applied these operations in this form, not we don't do any other things. Okay, for this the 3 operations were taken. Okay, these are not random. From this, the very basic thing, I think if you go through after this class, if you go through some examples, I think you will be able to understand all the thing very much clearly. So this is for all my video. Thank you.